These are just review problems of things from the beginning of the chapter that will help us get ready for the test. So we're going to start with 4r times s cubed times the quantity 3r squared s minus 2rs squared. And we want to simplify that. Now, what simplify means here is a little vague. What I mean by it is we want to get rid of the parentheses. Let's eliminate parentheses from this expression. So because it's multiplication, it's this times this quantity, we can do the distributive property and multiply this by that and also multiply it by that. We'll distribute this into the parentheses. 4rs cubed times 3r squared s. 4 times 3 gives us 12. R times r squared gives us r cubed, and s cubed times s gives us s to the fourth, minus 8, 4 times 2 is 8, r times r is r squared, s to the third times s squared gives us s to the fifth. And that is as simplified as it's going to get. We can't combine these two terms because they're not like terms. The exponents on each of the variables is not the same. S to the fourth and s to the fifth can't be combined. R to the third, r to the second can't be combined. So what did we just use here? We really used the rule of exponents that says if you've got a base and you're multiplying together, you can add up the exponents. X to the m times x to the n equals x to the m plus n. You add up the exponents. That's really what we took advantage of here, particularly if you look at the last term. S to the third and s squared became s to the fifth. Let's look at another one. Oops, I'm going to just... All right. 3 to the negative 1 plus 2 to the third, that quantity to the negative 2 power. Also 3 to the negative 1 times 2 to the third, that quantity to the negative 2 power. It might be tempting in this first one to distribute the negative 2 exponent in here and say this is 3 to the negative 1 to the negative 2, that is 3 to the negative 1 to the negative 2 plus 2 to the 3 to the negative 2, 2 to the 3 to the negative 2, and then use the rule of exponents that says we can multiply exponents in this instance. When we're taking it to a power, we multiply those exponents and call that 3 squared plus 2 to the negative 6th and go from there. That might be tempting, but it's also very, very wrong. Because there is no distributive property for exponents. If it's addition inside here, we can't put the exponent on each thing inside. We have to simplify what's inside the parentheses first before we can deal with the exponent that's on the outside. So, the way we really should think about this then is I'm going to ignore the minus 2 on the outside of the parentheses and instead just think about what's inside. 3 to the negative 1, that negative means reciprocal. So 3 to the negative 1 is 1/3, and 2 to the third is 8. So we've got 1/3 plus 8. Well, that's 8 1/3, which is the same thing as 25 thirds. That's what's inside the parentheses. That's still being raised to the negative 2 power. That exponent has two pieces to it, a negative sign and a 2. The negative sign flips it over. So it becomes 3 over 25. We've dealt with the negative sign. Now we just have to deal with the 2 exponent. And we can apply that to both parts of the fraction. 3 to the 2 is 9. 25 to the 2 is 625. And our simplified form of this expression right here is 9 625ths. Compare that to this one. When it's multiplication, we are allowed to apply the exponent to each thing separately. And so this becomes 3 to the negative 1 to the negative 2 times 2 to the 3 to the negative 2. And now we'll multiply our exponents and say this is 3 to the positive 2 times 2 to the negative 6. 3 to the positive 2 is 9. 2 to the negative 6, again, that negative means I'm doing a reciprocal. It's going to be on the bottom of a fraction. And 2 to the 6th would be, let's see, 2, 4, 8, 16, 32. This is 64. So we've got 9 times 1 64ths. 9 64ths is our answer. Okay, one more example to see, just to refresh our memory on this. Oh, by the way, the rule that we used on this was rule number 4, as I've got it on this list, says when we take something to a power and then raise that to another power, you multiply the exponents together. This cheat sheet of rules of exponents is available as a link on the blog. Last one. 3 times a to the negative 2 to the third power times 3a to the fifth. So again, I can apply this exponent to everything inside here. And so just dealing with this first piece right here, we might say that's 3 to the third times a to the negative 2 to the third, which I'm just going to leave that as 3 to the third for now. And a to the negative 2 to the third is a to the negative 6th. Then we might think about this part. What we don't want to do is try and apply this exponent to the 3. If there's no parentheses, the exponent only touches the one thing it's right next to. If we want that 5 to apply to the 3, we would need parentheses around the 3a. So since it's not there, we just have a 3 to the first, just a plain old 3, and an a to the fifth. Now we can add our exponents on things that have the same base. 3 to the third times 3 to the 1 is 3 to the fourth. A to the negative 6th times a to the fifth is a to the negative 1. And if we want to write this without any negative exponents, we might say, well, that a moves to the bottom since it's got a negative exponent. And 3 to the fourth is 81. And so the simplified form of that would be 81 over a.